Okay, let's do a couple examples of this concept. First one, which of the following functions grows the fastest as x grows without bound? So we have three options here, three functions, and we really have three possibilities. Let me refresh your memory on the last video, which says that if the denominator is larger, this one grows faster than this one. So f of x is slower, this one will be the faster one if we approach 0 as x goes to infinity. On the second one, this is the smaller one, this is the larger one. So f of x grows faster if we approach infinity. And if these are about the same, it means we're going to get a constant when we do this limit. Okay, so let's go back to this problem. So really we just need to start making fractions out of these. Let's start with a and we'll divide it by b. Let's see what happens. Now, if you remember the shortcut to the horizontal asymptotes, we can do this one quickly. That's technically not calculus though. So let's do the calculus way because this is how you can do pretty much all the limit to infinity problems. What you do is you take the highest degree in the denominator and divide every term by that value. So we're going to divide everything by x cubed, every term. So everything in the numerator, everything in the denominator gets divided by x cubed. You're allowed to do that. It's technically like you're multiplying by 1 there or dividing by 1. So simplify, those x cubes cancel, these x cubes cancel, and we're going to end up with 4 over x squared there. Now there's a limit rule. It's a known formula where if you take the limit as x approaches infinity and you have a constant over a function with a power, this is going to equal 0. I mean, just think about it. You're going to take 4 and divide it by infinity and square it. Infinity is giant, big giant number. So pick the biggest number you can think of, square it, and put it in the denominator. It's going to be like 0.000. So this ends up being 0. And we end up getting 2 divided by 1. So this is a constant. A and B grow at the same rate because we just calculated this limit as it approaches infinity, and it equals a constant. So A and B grow at the same rate. Let's see what happens now if we take A and C. So this is another rational function. This one's a little different, so that's why I showed you the calculus way of evaluating a limit as opposed to just doing that shortcut you might have learned in pre-calc. Because here, the highest degree is not x to the 6th power. Like here it's x cubed. You want to try to do this in a sneaky way. The highest degree in the denominator here is actually the square root of x to the 6th power. And if you remember, when you take a square root, if you rewrite it as a rational exponent, it actually looks like that. So the numerator and the denominator, they kind of have the same degree. So let's move forward with this and do it the calculus way. Again, we're going to do the same thing. We're going to divide everything by the exact same term, but it's tricky because we're taking the denominator dividing by the square root of x to the 6th and the numerator dividing it by x cubed. These are the same. They are the same, identical. So we're allowed to do that. Again, it's like dividing by 1 or multiplying by 1. So, and rule with radicals is if you're dividing radicals, you can just put it all under one giant, like you can make this one big radical here. So we can divide, the x cubes cancel, this looks like one giant radical, and now we can simplify this. So this ends up being 1 and then 1 over x to the 6th. Oh, I'm sorry, that should be a 5. All right, so now, same thing, we're going to use that limit property where if you take the limit as, it should be a 5, ignore that. Either way, it comes out to be a 0. And you end up with 2 over 1 again equals 2. A and C grow at the same rate because we approach a constant. So now here's an awesome thing that you learned like way back in, I don't even remember, Algebra 1 maybe. It's called the transitive property. Since A and B grow at the same rate and A and C grow at the same rate, then B and C also grow at the same rate. It's called the transitive property. Okay, so D is the final answer here. Okay, let's do another one. So compare the growth rate of the two functions here. So let's make them fractions and see what happens when we do the limit as x approaches infinity. So we have f of x over g of x in this case. We got to just see if it's going to equal 0, infinity, or a constant. So now this is tricky. It's kind of like the last one where you have to be sneaky about it because we're dealing with exponential functions this time. However, if you notice, they all have base of 3 in common. So we can actually rewrite this using base 3 for all of those terms because 9 is really 3 squared. And if you remember, here's a rule. If you replace the 9 with a 3 squared and raise it to the x power, it equals 3 to the 2x power. You multiply those in that situation. And the same goes for 81. That's actually 3 to the 4th power. And then same rule, you multiply here. So we can rewrite this as 3 to the 2x power and 3 to the 4x power. And now they're all in base 3. So let's use the same rule where we divide top and bottom by the exact same thing. And notice the denominator is going to be the square root of 3 to the 4x power. If you put that in rational form, it'll be 4x that goes in the numerator, the root is the denominator. So it actually is the numerator again. So even though it looks different at first, they're actually the same. It's tricky like that. Okay, so we're dividing everything by the square root of 3 to the 4x power. This is going to be 3 to the 2x here in a second. And we can divide this and we can divide this, and this cancels out to make 1. You can cancel one of those x's, and we're going to get 1 over 3x here. Oh, I'm sorry, we can cancel the x's and get 1 over 4. Let me say that right, huh? Okay, so we divided by 3 to the 4x power, top and bottom, square root of that. This simplified to 3 to the 2x. These two canceled with each other. 3 to the x power and 3 to the 4x power, we can cancel those x's and we're left with 3 to the first power in the numerator and 3 to the 4th power in the denominator. Just want to make sure we're all clear up since I kind of messed that up. Okay, moving on. We can cancel one of those 3's. It's kind of like 3 over 81 right now, so simplify that fraction. You don't have to write it as 3 over 81. You can just think of it as like, what if it was x to the first power over x to the 4th power? Well, that's just going to be 1 over x cubed. It's the same thing. It's just 3 is the base instead of x. So now you have 1 over the square root of 1 plus 3 cubed. That's 1 over 27. We don't really have to worry about this right now. It's a constant. Again, they're going to grow at the same rate because the limit approaches a constant again.